Okay, in this problem now, let's have our domain be the real numbers. All right, the real numbers. This is basically anything you can think of, except for the imaginary numbers, except for the complex numbers. So the real numbers, that's what you use in calculus. All right, so now let's think about let's try and decide whether or not this statement is correct. Now what this is saying is that for all real numbers k, there exists some real number n such that the absolute value of 1 minus n squared is less than k. All right, let me try and explain that a little better, or bring that down to real life. It's saying that no matter what k you pick, you can find, no matter what real number k you pick, you can find some real number n such that the absolute value of 1 minus n squared is less than k. All right, this is false. Now let me show you why. Okay, so remember that absolute value, whatever you put into absolute value, this thing is always going to be greater than or equal to 0. Right? This thing is always going to be positive. In fact, let me put this over here. Greater than or equal to 0. Let's put this over here like this. Okay. Okay. And so that means that 1 minus n squared, no matter what n you pick, is always going to be greater than or equal to 0, because it's, or the absolute value of it, right? The absolute value of 1 minus n squared is always going to be greater than or equal to 0. That's just absolute value does that. Right? If it's negative, if you put a negative in there, -4, it returns positive 4. Put 0 in there, and you get 0. Put positive 4 in there, it returns positive 4. So absolute value of 1 minus n squared is always going to be greater than or equal to 0. Now, what this is saying for all real numbers k. For all real numbers k, meaning no matter what real number k you pick, there's got to be some n such that the absolute value of 1 minus n squared is less than k. All right, so this is not true for all real numbers k. Specifically, it's not true for the negatives. Let's say that k is -1. If k is -1, then what this is saying is that if k is -1, it's saying that there's got to be some real number such that its absolute value of 1 minus that number squared is less than k. But you see, the absolute value is always positive. It's always greater than or equal to 0. So what this says here, right, is that 0 is less than -1, which is not true. Right? It's clearly not true. I mean, there are some k's for which this is true, right? But it's not all of them, and that's the point, right? There are some k's for which this is true. Let's look at some of those. Let's say k is 10. If k is 10, there is some number, there is some n here. Let me make this a little better here. If k is 10, then we can find some n, some real number n, to put in here to make this true, right? let's see, if k is 10, what's something that can go in there? How about, I don't know, 0 would definitely work, right? Because the absolute value of 1 minus 0 squared is 1, and 1 is less than 10, so that would be true. Right, so that's one time, that is 1k for which this is true. And it's true for all of the positive k's. But the problem is this is a for all, right? For all k. It's saying that no matter what k you pick, you can always find something to go in here to make this true. And it just doesn't work when you make it negative, when you consider negative real numbers. So negative 10. There's no number that you can put in here that when you take the absolute value of whatever you get there, because absolute value is always positive, that you're going to be less than negative 10. So this is false. All right, so now let's look at another situation. Let's reorder the quantifiers. There exists k for all n. Now, is this true or false? Is this true? Is this false? Let's think about this a little more. Okay, so remember the domain is the real numbers, and we're dealing with there exists k for all n, that the absolute value of 1 minus n squared is less than k. So let me just show you a nice way to deal with this problem. Now let's disregard this stuff over here. Okay. So first, let's consider the function y equals 1 minus n squared. You may remember this has a graph looking something like this. 1 goes through at 1 there and at negative 1 there. That was my daughter. if you heard some squealing. All right. Okay. So that's 1 minus n squared. Now, if you think, you may remember from other classes, what does the absolute value look like? Okay, so the absolute value, if you think about it, right, if you take the absolute value here of this thing, then what happens is all the negative parts get reflected across the x-axis. Okay, so then the graph of y equals absolute value of 1 minus n squared looks like that. All right, let me erase this other stuff here. And now we're trying to decide, is there exists k for all n, absolute value 1 minus n squared less than k. Is that a true statement? Okay. Right, so here's the graph of y equals, I'm just going to rewrite this so down here, 1 minus n squared, like that. Get rid of this, right there. Okay, so what this is saying is that there exists some k, right? There exists some really special k such that no matter what n you pick, this function, whose graph we have right here, is less than that k. I don't want to give it away just yet. Oops. All right, so this is saying that, let's see, suppose that that was the k, right? This is saying there exists some k. Well, let's see, how about maybe that's the k, right? Such that for all n, 1 minus the absolute value of 1 minus n squared is less than k. But look, this graph is increasing without bound. It just gets bigger and bigger and bigger. It can get as big as you want it, right? So it gets bigger than that k, so it's false for that k. Right? Well, maybe it's some other k, like how about 1,000,000, right? Or let's just say 10 to the 10 to get really big, right? But this thing increases without bound, so it's going to get bigger than that too. So there doesn't exist a k such that this function is bounded. This is unbounded. It's not bounded above. This function is not bounded above. And so if I was to give an explanation for why this is false, I would say not bounded above.